A perfect square was a word of the day that we had at the beginning of the year. Perfect square is the result of multiplying a number by itself. A characteristic of a perfect square is always positive because a negative times a negative is positive. I entered -2 squared on my calculator, and this is what I got. I got a -4. This surprised me because I knew that perfect squares are positive, right? Well, -2 squared here is different from the expression I see here. You might think that this also says -2 squared. A key thing to know here is that a negative sign to the left of a variable or a number is the same as -1 times that. So this is -1 times 2 squared. Whereas here with the parentheses, we can see that as -2 times a -2. So if this expression is positive, what about -2 to the third? Another way to ask this is if perfect squares are always positive, what about cubic numbers? Cubic numbers was also a word of the day. Cubic numbers are the result of multiplying a number by itself 3 times. An example of this would be -2 to the third, where I'd be multiplying -2 by itself 3 times. We know that -2 squared comes out to be a +4. And so if I multiply that by another negative number, I would get -8. So cubic numbers can be negative. What if we kept going? What about x to the fourth or x to the fifth? If we continue to look at powers of 2, we would have -2 to the fourth and -2 to the fifth. Here I'm multiplying -2 by itself 4 times. Here I'm multiplying -2 by itself 5 times. So we know that -2 cubed is a negative number. And if I multiply that by another negative, it would come out as positive. Let's take a look at -2 to the fifth, right? Where if I group this, here's a group of 3, I know that would be a -8, right? And then if I group these numbers, I know this would be a +4. So a negative times a positive would be negative. What this means is that a negative base with an even exponent will be positive, and a negative base with an odd exponent will be negative.